that they will fall within that line of regression. So probability is a percent. The most it could be is 1. So you could say 33% of the data will lie within our regression line. It's not a direct. So like if you look.
Right, I'm trying to think of, like, if you get an R value of 0.7.
That's really high R value.
Yeah, but you square that, that's still gonna say that the 50% of your data, or 49% of your data
Right.
can fall within that. Okay. That makes
Right.
sense, I guess.
We'll fall in that prediction area.
Right.
Yep. Okay, so this is a weatherman prediction analysis here. So we got these are the temperatures and the actual temperatures, the predicted temperature and the actual temperature. I don't know if this data is skewed or not. I feel like it's not reliable.
It'd be nice if they were different colors.
If what was different code?
Points.
Oh, so you can tell if they're overlapping or something? Sometimes they'll do that if they're common points. You just kind of want to see, are they clumping together in a pattern or not? And so it looks like they're getting bigger from left to right. And R squared is 0.37. So if you take the square root of 0.376, you get the R value. Okay? So when you're talking about, and I said we're not gonna do the full-on hypothesis test. We're just going to talk about, is that a strong or is that a reliable prediction? How good is this prediction? So take the square root of that 0.376. What do you get? 0. What? 0.61. Now, according to the social behavioral scientists, that would be a really strong correlation. Okay? We know it's positive. We know it's at least moderately strong. 0.376 means weatherman's right about a little more than a third of the time based on where he should be on this data. Okay? And since we did that other example, we're not going to calculate each one of these. Is this interpolation or extrapolation for 35?
It's like it's extrapolation because your lowest score. Oh, interpolation. It's interpolation.
Interpolation, but we might want to be tossing this one out of here, right? Depends on what. But that's interpolation. That I would be more confident about 40. 65 would be extrapolation, and 25 would be extrapolation. Okay, so.
65
Well, it
is,
looks like you have scores that go to almost.
Oh, I'm sorry, 60. Yeah, 65 is probably okay. 25 would be the extrapolation. Yeah, put my hand on the wrong spot. Okay? So, if we did the full-on hypothesis test, okay, I just want to show you how this works out. There's degrees of freedom, just like there was with the last one. There's a way you find it. We use our R squared value. And you know what? I'm not even going to show you this because I don't want you to have to think about it. So we're not going to do it. Unless you're going to be disappointed by it.
No.
But, okay, so in hypothesis testing, it's very similar though, right? There's some kind of way that we're going to get our number off of a chart in the back of the book that tells us our reliability area. And we got to see if it falls in there or not. If it does, you can reject the null. Okay? So in this case, the weatherman is correct enough. It should be, I guess. But.
It's the computer.
So if you are wanting to do, if you didn't do these calculations on here, or the ones that pop up, you do not need to know how to do the top part. I'm going to try to mark on here. values. So if you want to cross this part off, if you printed off your notes, you don't need to find the critical values. You need to be able to predict. So plug it in.
It's the last slide. But the chart
We don't have the last one.
You don't have the slide?
We don't have this list.
Is it covered up though?
It's the very last slide.
Yeah.
I mean, the next to last slide, and it has a graph on it. It's that
So
one.
delete
When
the
he
graph.
clicks on it, that graph falls off and it shows everything.
There. Boom. This one?
Yeah.
So I could just make the graph
So-
small.
So we don't have.
So on your computer, I'm just saying, if you're wanting to check some predictions, you could do that. Don't do this top part, is what I'm saying. We scrap that on interest of time. Okay? So, for your homework, we have the template. We already got more data. You didn't get all 20. You don't need 20 beyond yours. You need 20 total. No males and height. No shoe size and height for males. You can do another male data factor. You can do the female data factor. Just can't do the one we did. Okay, that'll be part of your homework assignment. That's one of the questions on it. Okay? Correlation has to be numerical, scalable data on X and Y axis both. That's the biggest key. And it does not mean it causes something. So I don't want to hear anybody say the word correlation again out of context. It's like swearing to a math teacher. Okay, let's take a little break. Time stopped when I moved the clock at 6:02. It is 7:13. Let's do it 7:20 because I want to get out of here by no later than 8 to get down to Computer Lab so we can get working on that.
Is there a branch of statistics that does causation, that looks at causation, or is that,
No, you would just,
you would never, there's nothing that you could ever test that
So-
says because of this, then that?
correlation is an initial test.
Right.
And
No, I
so,
understand this part.
right. So then if you're a statistician,